Good evening, everyone. Am I audible to you all? Please confirm if I'm audible. Okay, thank you. So today's topic is Enzymology, Bioenergetics and Thermodynamics from Unit 1. Okay, these would be mostly part C questions. Yeah, I'm good, Satyam. Thank you so much. I hope you all are also doing well. Take care of your health and keep revising extensively, keep practicing questions regularly, and give at least I don't know what your daily schedule is, but try to donate at least some 5 to 6 hours daily so that you can revise well for your exam. Okay, moving on to the first question, which is from enzymology. The rate constant for the conversion of a substrate into a product is 10 to the power minus 4 per second. And the reverse rate constant is 10 to the power minus 6 per second. That means 10 to the power 4 substrates converted into product per second, and this is the reverse one. So we know that enzyme and substrate, this first makes enzyme substrate complex, and then this makes enzyme plus product. So this forward rate constant, which is generally called as K1, this is given to be 10 to the power minus 4 per second. And if you take reverse rate constant, which is k minus 1, it's considered, this is given as 10 to the power minus 6 per second. An enzyme enhances the rate of this reaction by 100-fold. That means the rate of reaction, what you can consider, that is velocity, by 100-fold, it will be faster. So what is the KEQ for this reaction? What is the K equilibrium constant for this enzyme catalyzed reaction? So what will be your strategy? Obviously, this is a numerical formula. Do you know of any numerical formula which is involving this rate constants K1, K minus 1? Are you aware of that? Yes. Anyone? If not, then I'll explain to you. No worries. Okay. Let's have an understanding. See, whenever we consider for any enzymatic reaction, like this is itself an enzymatic reaction. Okay, let's say E plus S, through this it gives you product. So whenever we say equilibrium, overall these are the reactants and overall these are the products. So whenever we say K equilibrium, it means the product concentration at equilibrium divided by reactant concentration at equilibrium. This is generally what we mean. Okay. So suppose that in the absence of enzyme, the forward rate constant is 10 to the power minus 4 per second, and the reverse rate constant is 10 to the power minus 6 per second. So K equilibrium will be given by simply taking the ratio of these two rate constants. Okay. So K equilibrium, that is 10 to the power minus 4, which is the forward, divided by the reverse, it is 100. Now they have said the equilibrium concentration of B is 100 times that of A. Okay, so as I told you here, B they have considered as the product. Okay, and A is they have considered as the reactant. Okay, so this is what we have. Now we need the concentration of B and concentration of A to get the K equilibrium. But if we take the ratio, we know the forward rate constant and reverse rate constant, it will be 100 times as the substrate catalyzes the reaction to 100 times. Okay. So we can say that the equilibrium constant, which means KEQ is also 100 times, that is KEQ is also supposed to be 100. Okay, so 100 is equal to the B or the product divided by reactant. That means if you take the product, it is 100 times that of the reactant. Reactant will come over here, no? So product is 100 into reactants, which means that it is 100 times of that of A, whether or not enzyme is present. But however, in the absence of the enzyme, the reaction could take more than an hour to approach this equilibrium. Whereas in the presence of enzyme, equilibrium could be attained within a second. Hence, the 100-fold increase in rate is there. Okay, so this particular value is not required to calculate the KQ. Alright, so that is why here correct answer is option 1. Right. Now, second question is from June 2021. This is also on kinetics, but this is a theoretical question. Not every time from enzymology you can expect to have a, numerical question always that you have to solve and get the answer. So many a times you will also get theoretical questions in enzymology, such as like this. We know that Michaelis and Mentane, they gave a kinetics in which they have assumed that we have to take this reaction, that is k minus k1 and k minus 1. Okay, this is the forward reaction to form es, so we can say this is the rate constant for formation of es, and this is the rate constant for dissociation of es. But es can also break down into e plus p, so this is a different rate constant which is given by k2, or which you can also call it as the rate constant of rate limiting step, which we can also compare with the value. Okay. Now, Michaelis Menten always have assumed, there is an assumption in Michaelis Menten that the K2, which is the rate limiting step, which means it is a slowest step. Rate limiting means it is slowest step. Okay. So rate constant of rate limiting step, it's always less. So that's why Michaelis Menten assume that k minus k1 and k minus 1, they are much more than k2. This is their assumption. What does that mean? That the rate of ES formation and the rate of ES break dissociation back into E plus S, those happen at a much faster rate than ES breakdown into product. Based on this equation, they have also formulated a term called as Km, which is Michaelis constant. It is actually equivalent to Kd, which is the dissociation constant, and in fact it is also equivalent to Ki, which is the inhibitor constant. All these are actually similar to each other. Okay, meaning is same and their formulation would be also similar. Okay, they all are inversely proportional to the affinity of the enzyme towards the substrate in this case and towards the inhibitor in this case. The formula for Km according to Michaelis Menten is K2 plus K1, sorry, K2 plus K minus 1 divided by K1. This is the formula of Km. Okay. Now, if you assume that K2 is very less, okay, so K2 is very less and K1, K minus 1, let's say this is value is 100, K1 value is 100, and K2 value compared to that we can take 0.1, let's say. It is very less, so we'll take just 0.1. Now, if we put 100 over here and 100 over here, and if we take 0.1 over here, now 100 plus 0.1 is almost 100.1, which is almost 100. So in this Michaelis Menten assumption, because of this assumption, in the Km calculation, we can ignore the K2. Okay, and K minus 1 is nothing, but it is equivalent to Kd value. This is equivalent to Kd value. Okay, so in Michaelis Menten kinetics, the Km, it is equal to the dissociation constant when the ES complex dissociates more rapidly than the product formation. So this B is the correct statement. Is it clear or not? Okay, Viranja, uh, ready? Hello, nice to meet you. You're from Guntur district. Okay, I am finishing BSc microbiology in 2017. I've completed. Okay, I want to plan preparation for Central University Common Test, how to get the entrance test syllabus. Okay, so you can write to Biotecnika. Okay, you can write to info@biotecnika.org. Um, just write info@biotecnika.org and our team will help you with what you need. Okay. The Michaelis constant is independent of enzyme concentration and substrate concentration. Yes, yes, you're right. Correct, Satya. Very good. So as you can see, Michaelis constant completely depends upon the K1 factor, K minus 1 factor, and K2 factor. No matter how many enzymes and how many substrate you have, this factor will still depend on its intrinsic property only. Okay, so option A is correct. Okay, and option B is also correct, but option C and option D is not correct. See, Michaelis menten is a intrinsic property of enzyme, correct, that is fine, but it does not depend and it says it is not depending on pH, temperature and ionic strength. Okay, so first of all, in this you have to select the combination of statements. Okay, so here the correct answer will be option 1, which is A and B. Okay, so A and B will be correct answer. So already I have explained to you that in kinetics, you assume that the K on, which I was saying as K1, and the K off, which is K minus 1, these are much more than K2, which is the K cat. Okay, so when you take the Km of kinetics, which is K off plus K cat by K on, you can ignore the K cat factor. So in that case, your Km will be equivalent to Kd. But this is what is according to But there is another one which is Briggs-Haldane equation. According to this equation, they did not take any such assumption. So for them, when you take the Km calculation, you cannot ignore the Kcat term. Okay, Kcat term you cannot ignore. In that case, your Km value will be more than the Kd value, because Kd value is K of value divided by K on. And if you add Kcat to it, then Km will be more. So according to Briggs-Haldane, Km will be more than Kd if you assume that the Kcat value is not less than K of. Okay. And as I mentioned, D is wrong because the value of Km is minimum at an optimum pH of an enzyme. It increases with the changes in the pH of temperature. So it's written that it does not depend on the pH and temperature, but that is not correct. Km value decreases if the temperature is increased until an optimum temperature. But if you take it any further up the temperature, it will decrease the enzyme affinity. Then it will increase the value of Km. That is why D will be wrong. You're supposed to select the incorrect statement. So that's why here correct answer is option 1. Okay. I believe this is clear to you. Now again another kinetics question. So this is also kind of numerical. This is a recent exam, just last exam that we had from June 2024. Okay, this is also a part C question. A propionate kinase enzyme utilizes two substrates. Enzyme is same, substrate is two different. One is propionate, another one is acetate. With Km for propionate being half of acetate. So if we take Km of prop, I will write just. So Km of propionate, if we take Km of acetate, okay, so it is divided by 2. This is what is Km of propionate. Now, which of the following options about the rate of reaction at very low substrate concentration is correct? Okay, so what you have to do is you have to use this Km and you have to put it in equation. Equation is V0 is equal to Vmax plus S divided by Km plus S. Okay. Now see, the hint of the question is at very low substrate concentration. Okay. You have to get the ratio of the propionate utilization. That means you have to get the ratio of how much is their velocity. Not Vmax, how much is their velocity. You have to take the ratio. Ratio of propionate divided by V0 of acetate V0 of propionate divided by V0 of acetate. That's what you have to get. Okay. So instead of Km, if you take V0 of propionate, then instead of Km, you will write Km of propionate like that. Okay. And separately, you have to calculate V0 of acetate. Okay. So for this, um, okay, Sakina, let's have a look. Now, first of all, see when they have mentioned at very low substrate concentration, what does that mean? It means that the substrate concentration is much less than Km. What is Km? If you have studied enzymology properly, you would know this. Km is the substrate concentration which is required to reach half of maximum velocity. Okay, so when the substrate is at a very low substrate, at least for reaching half of maximum velocity, you need lots of substrate, right? But if it is saying very low substrate, means the substrate is much low than Km, which means you can actually, sorry, there is no multiplication here. I mean, there is no plus, this is multiplication. Okay. So if it is substrate, then you can easily ignore this substrate part since it is in addition. The same logic applies here. Let's say Km is 100 and substrate is 0.1. So 100 plus 0.1, it will be almost 100. So the bottom, this term you can almost ignore. Okay. Significantly faster than the rate of with acetate because a lower Km indicates a higher affinity, do you say? Okay, so we have to actually calculate that. Okay, so let's have a look. See, at a very low substrate concentration, if we take at a very low substrate, then see the denominator, what we had Km plus S, we can ignore the S and it will be just the Km term. Okay, so if we take Km propionate, it's already given that it is Km acetate by 2. So first we will calculate V0 of propionate. So let's put it in the equation, that is Vmax into S. Okay, Vmax into S divided by, you have to take acetate by 2. We saw no Km propionate was Km of acetate by 2. So this is your equation. V0 is equal to Vmax into S and divided by Km of acetate by 2. So when you take this and you will take it for proper ratio. See, when we write like this, it's not clearly visible probably. So I'll write it for you. V0 of propionate is Vmax into S divided by Km of acetate divided by 2. So this will get reversed. We will write Vmax into S into 2 into Km of acetate. So basically we will have 2 into Vmax into S divided by Km of acetate. This is what we are getting V0 of propionate. Okay. And if we have to calculate V0 of acetate, then it's just Vmax into S divided by Km of acetate. So that's what we have. So this is the V0 of acetate and this is the V0 of propionate. You can see the difference is only in the two. Okay. So if we take the V0 of propionate, that is V prop divided by V acetate, it will come 2 by 1. Okay. So see, V propionate divided by V acetate is 2, which means that the propionate velocity is twice the velocity of acetate. Okay. So yes, Sakina, very good. Your answer is right. Option 2 is the correct answer. Did others follow? So Sakina, had you seen this question before or you have just solved it? If you have just solved it, that means you are very well prepared for your CSIR exam, upcoming CSIR exam. So I just want to remind you that if anyone feels these questions you are not able to solve, then I will suggest that you join the Lakshya batch, which is for the next exam, CSIR NET 2025, and also it will help you prepare for GATE 2026. So it is like two, with one arrow, you will be hitting two targets. Okay, along with that, you will also get a free molecular biology internship and the obvious features of Biotecnika classes, that is unlimited classes till then, as much many classes you want to attend, 24 by 7 chat support, dedicated study portal, Conceptica series free access. So your exams are upcoming. In case you want the revision tools of Biotecnika, then also you will be getting along with that. And even the test series will be also a part of it for you to practice more questions. Okay. All right. Next question is from June 2021. This is regarding feedback inhibition. That's wonderful, Sakina. So very good. You are well prepared for CSIR NET. Just keep on revising other topics as well. Okay. So any idea what is this type of feedback inhibition? See, when it comes to preparation for CSIR, you have to focus on the details which are not so obvious. When you generally study enzyme inhibition, feedback inhibition will be a part of your study course probably, but you may not look into the types of feedback inhibition. Okay, but then if you go in any standard review article of feedback inhibition, then these types will be mentioned. And in fact, when you're doing research, sometimes especially with bioprocess, if you're doing any research in industrial settings, then this type of metabolic pathways you may be expected to know how we can engineer them and manipulate them for the best production. Okay, so under this you will see they have given the end products K and L. They are asking under which of the following conditions would stoichiometric amounts of end products K and L be obtained if a concerted feedback were in operation. They have already given that this is a concerted feedback type. Okay. So which out of these, which one is that? Satyam, can you tell the option number 1, 2, 3, 4? Yeah, they will be, see, they have given stoichiometric amounts of end products KNL, isn't it? So, generally in concerted feedback, what will happen? F is a common product which is going for the production of G, okay? And it is also going for the production of H. Now, feedback means too much of end product is there, it will stop its own synthesis by inhibiting an early enzyme. So K generally goes and inhibits the enzyme which converts F to G, whereas L goes and inhibits the enzyme which converts F to H. Okay, so option 1 makes more sense, that K inhibits F to G conversion and L inhibits F to H conversion. Now, if F wants to be inhibited, okay, sorry, if K and L they are having at equal amounts, they have said stoichiometric amounts will be there. So if both are there, then they will go and inhibit the conversion of D and E. If alone K is there, then it will go and inhibit only this. If alone L is there, then it will go and inhibit this. But if you have equal amounts of K and L, then both of them will go and inhibit the conversion of D and E. That is what is meant by concerted feedback. Okay, so the correct option is option 1. So just to tell you that according to the representation of certain feedback reactions that are predominant in metabolic pathway, in concerted feedback inhibition pathway, end products inhibit their own synthesis by blocking their respective enzymes, and also more than one product or all the end products must be present in excess to repress the first enzyme. Okay, so this is what is concerted feedback. See, the D X is prevented by its own synthesis. Y prevents its own synthesis, and if they are present equal amount, then they will be inhibiting the first enzyme. Just so you know, there are other type of inhibitions as well. For example, you can take cumulative inhibition. Just now we saw concerted. So what is cumulative? X and Y, the end products, they don't have to be equal. They will be together. Cumulative means together they should be able to inhibit the end product, but they need not be in equal concentration. Okay. Monovalent means out of the end product only one of them will inhibit the first enzyme, so other one will be inactive, it will not be able to do anything. Divalent means both of them will be able to do. So you can say under divalent, but they are not able to inhibit at multiple levels. Okay, they are only able to inhibit the first enzyme. Then sequential feedback is there. First these all will be inhibited, then D will go and inhibit its own synthesis. Okay, so these kind of things. And isofunctional means at the same time they can inhibit both the type of enzymes. Okay, they don't independently. They don't need to be together. Independently they can inhibit this enzyme also and the previous enzyme also. So you should know these things as well. Then another question from Enzymology, CSIR NET, November 2020 question. Okay, here they are asking about the Hill equation. Hill equation is for a straight line graph. When you talk about protein and ligand binding, or if you talk about enzyme and substrate binding, generally when we have this P plus L, it gives you PL complex, right? If you have, let's say theta is the binding equilibrium, means how many are occupied with ligand. So theta, which is the binding equilibrium, how many ligands have, how many free binding sites, protein binding sites are occupied with ligand, divided by total binding sites available. So total binding site means already the ones which are bonded with the ligand plus the ones which are free protein. Even they have a binding site, just that they are not already bonded. So this is total binding site and how many of them are bonded. Now see, the maximum value of theta can be 1. That is when total number of PL complex, let's say you have 10 protein molecules, okay, and 10 ligand, okay. So at certain point of time, you got 5 PL. So in that case, it will be 5 divided by 10 plus 5, isn't it? Sorry, it will be 5 plus 5, because if 5 is used up, then 5 is left, okay. So this is what is left. But if all of the proteins are now bonded with ligand, so you have 10 and then free protein you have 0, because all of them are bonded with ligand. So in that case, if you have half of them bonded, then the value of theta will be half, is 50%. Okay. But if all of them are bonded, then the maximum value of theta will be 1. This is the same thing as you can take in enzyme substrate. Okay, so if enzyme substrate complex is formed and enzyme substrate plus free enzyme, this is what you have. So basically, if enzyme substrate is bonded with each other, then you have nothing but Vmax, isn't it? You have Vmax, and V0 is the binding equilibrium, how much of the enzyme sites are occupied, right? So basically we have actually, if all the sites are occupied, then it is Vmax, whatever total sites are occupied, okay. And you will have, out of that you have Vi is how many of them are bonded. So it is the same thing, as you can say, in the same format as that of the theta, which is the binding equilibrium. Okay, so generally the Hill plot, it is plotted under the equation, straight line graph equation, mx y is equal to mx plus c. All right, so whatever you are getting from the equation only, not equation, from this protein plus ligand gives you PL complex. So from here we will be taking a certain kind of, that is theta, what I told you, PL divided by PL plus P. Okay, so from here only we will do some changes, okay, and we'll take log on both sides. We will simplify it and we will get in this form. Okay, when we get in this form, we will see that y is coming to Vi divided by, Vi means nothing but V0, divided by max minus V0 is equal to m log of substrate, okay, plus C. So C and M also has value, okay. So basically what you have in the place of y and in the place of x, that's what we'll plot in the axis, x and y and x axis, okay. So option C is correct over here, that they have what is plotted in the Hill plot. It will give you a straight line graph equation, and this is always cooperative kinetics. See, when you have, yes, that's right, very good Satyam, that's the right answer. So this is what is your Hill plot. As I said, the V0 can be considered to be y over here, which is the fractional saturation. So for the protein and ligand, it will be theta, log theta divided by 1 minus theta. If you take the same thing in enzymes, it will be log V0 divided by Vmax minus V0. So this is how you get, after solving that equation, no, from theta, this is what you would get in the y-axis. So if you do it with enzymes, this is what you will get. So that's why C is correct. So the entire equation in that intercept, that is C, what you get, y is equal to mx plus c. So that c is minus log kd, which means that if you take from the straight line graph equation where it is meeting in the y-axis, okay, so that point will give you minus log kd wherever it is meeting the y-axis. Okay, so whenever you have a straight line equation and there is no slope is equal to 1, okay, then oxygen binds to each side with the same affinity irrespective of the number of oxygen bonded to other side. So in that case, hill plot will be linear with a slope of 1. Okay, but on the other case, if you have like hemoglobin or something or any other cooperative protein, which in which binding of one ligand will enhance the binding of ligands on other side, in that case you will be having slope more, which is 2.8. So this implies that there is maximum cooperativity in the middle of the binding curve. Okay, so that's what this is. The equation which I was talking about, log y 1 minus y, this is only the Hill equation. As I said, y is the saturation equilibrium or binding equilibrium. Okay, and when you have a slope of more than 1, it means the um, protein or enzyme is cooperative with the substrate. All right. Next, September 2022 exam. A student was asked to plot a graph representing enzyme kinetic data for initial velocity, substrate concentration using any of these equations given below. The student used an equation for which neither x-axis nor y-axis should have independent variable. So generally for enzyme graphs, what do we have in the x and y axis? So first of all, what all graphs do we have? We have the equation graph, okay, in which we have the velocity and the substrate. So that is a rectangular hyperbola. Then if we take Lineweaver-Burke plot, it's a straight line graph equation. We have 1 by v and then we have 1 by s. It is a double reciprocal plot. Apart from that, we have Eddie-Hofstee plot and Haynes-Wolff plot. Okay, so Eddie-Hofstee plot, see, this is the equation, graph, where we take V0 divided by substrate, V0 versus substrate, 1 by V versus 1 by substrate. Then we have the Haynes-Wolff plot, where we take substrate by velocity in y-axis and only substrate in the x-axis. Okay, and Eddie-Hofstee plot, we will take velocity like same as equation, but in the x-axis also we have velocity and substrate. If you see in this 3, in the x-axis we have only substrate terms, either plain substrate or reciprocal of substrate. But the Eddie-Hofstee plot is the only one in which we have V0 by S. Okay, V0 into S. So V0 term, velocity term, is there in x-axis also and y-axis also. So the question was, which of the following equations students might have used? So he used an equation for which neither x-axis nor y-axis had independent variable. That means both had dependent variable. When such confusing questions are given, confusing statements are given, you should select either, I mean, you should read it in your own way. Neither x nor y had independent means neither of them had I mean, they should have had dependent values. They didn't have independent means they should have dependent values, and dependent values in both x and y axis is possible only when velocity term is there in both of them. Okay, like as in Eddie-Hofstee plot. All right, but substrate concentration is not dependent variable. Okay, so that is why in the other 3 graphs, as in this one, this one, this one, only the y-axis had dependent, but the x-axis has independent value. Okay, fine, you figured out which graph you would have used, but what equation? So for this you need to know the equations also. This is MM equation, this is a Lineweaver, this is Haynes-Wolff, but they have not given in the same format. Okay, so this all is straight line graph equation. So all of them will be in the form of y is equal to mx plus c. Okay, even here also y. So in the y axis you take s by v. Here also you take like that. Here also mx plus c. So you can see here also it is y is equal to mx plus c. Since here slope it is minus km, that is why you are seeing a reverse line over here in eddy Hofstee. It has a negative slope. All right. So 1 by v0 is equal to km by vmax. This is the Lineweaver-Burke plot. Okay. All right. Then S by V0, S Vmax plus Km Vmax, as you can see, S by Vmax, Km Vmax. So this is the Haynes-Wolff plot. Even this has, so this also has dependent values, right? I mean, this has dependent value. Then V0 is equal to Vmax into S divided by Km plus S. Even this is MM equation. So this one is also not the answer. This one is eddy Hofstee plot. So you don't, this is not in the eddy Hofstee plot format, because eddy Hofstee is equation is this, eddy Hofstee equation. So you may have to solve it a bit to get this equation, but instead of that, if you simply cancel out that this is Lineweaver, this is Haynes-Wolff, this is Michaelis-Menten, then directly you will be left with only one answer, which is option 3. Yes, very good, Satyam, that's the right answer, correct. Okay. Then again, from the recent exam, June 2024, this is regarding enzyme inhibition. So they have taken an enzyme that has a Km of 1 millimolar. Okay, enzyme has a Km of 1 millimolar, but they have taken the enzyme in the presence of an inhibitor also. There is a inhibitor presence as well for this, and there are different like options which are given where the Km and Vmax are changing in different proportions. Okay, so addition of different inhibitors, in all of these different inhibitors are given which changes the Km or Vmax, and it is written as Km app or Vmax app for apparent. Okay, because it's not the original Km, it's a changed one. So which out of them will result in the lowest rate of enzyme catalyzed reaction? Okay, that means they should be having the least Vmax. Rate of enzyme catalyzed means the decrease should be least. Okay. Now, if you see the first one, Km app is equal to 5 Km. That means with inhibitor, the Km increases up to 5 times. First of all, we are not interested in Km. It's only asking about rate. So Km will not be important here. We just look at Vmax, which is 2, 3, 4. Now in the second one, Vmax decreases 5 times than the original Vmax. Vmax by 5. Vmax app or Vmax apparent is Vmax by 5. In the third one, you can ignore the Km. Here in Vmax is decreasing by 2. Okay. And in the fourth one, Vmax is decreasing by 3. Right. So obviously the lowest will be in this one. So further, this was a very simple question. They could have asked what type of inhibition is this, okay, in which Vmax decreases, but Km doesn't decrease. You can see that they have made it too simple. Obviously, answer is option 2, but they should have given what kind of inhibition is this. So can you tell me what kind of inhibition Vmax decreases, but Km remains the same? So if you are well prepared for enzymology of unit 1 for CSIR, you should be able to answer this. So I'll give you a hint. The first one where only Km increases but Vmax remains the same, this is competitive inhibition. Okay, these are all reversible inhibitions. This is competitive inhibition. Km increases but Vmax decreases. Okay, even here also Km increases, Vmax decreases. So both of them, Km increases and Vmax decreases, both of them are examples of mixed inhibition. Okay, mixed inhibition. If this was Km by 2, that means Vmax also is decreasing, okay, and Km is also decreasing, then it would have been uncompetitive inhibition. Okay, yeah, Satyam, that is right. I was asking what kind of inhibition is this in which only Vmax decreases. The answer is non-competitive inhibition. Okay, so that is a very simple question, but still students felt confused. So sometimes the same simple questions might seem that you might be little suspicious. How come they have given such a simple question? Okay, all right. So I want to remind you about the Lakshya batch once again. If you want to join this batch, then don't hesitate and don't delay, because our seats will be limited and later you might not get entry to this batch. Do contact our toll free number today in order to join this batch and get a guaranteed success for the upcoming exams. Next question, from again June 2024 only. This is also from June 2024. What is the fold difference between if you take V at substrate is equal to K, and if you take substrate at 1000 K? So this is a very simple one. You just have to use the kinetics by substituting S with Km in one of the equation and substituting S with 1000 Km in another equation. So let's say V01 is equal to Vmax into S. But here instead of S you will write Km divided by Km plus S. Again instead of S you will write Km. Okay. So your V01 will be 2 Km Vmax plus Km divided by 2 Km. Okay. So you take the km to the other side. So it will be V01 into 2 km is equal to, sorry, this is not into, this is multiplication. Okay. So here km gets cancelled. Okay. Here km get cancelled. So basically you take the 2 over to the other side. Okay. Or else you can simply write V01 is equal to Vmax by 2. This is your first one. Okay. Now, what is your second one? So, I'll just write V01 is equal to Vmax by 2. Fine. Now, your V02 you have to calculate. V02, again we will take Vmax into, so this time substrate we will take 1000 km. So, this is 1000 km divided by km plus, again instead of substrate I'll write 1000 km. Okay. So, here it will be Vmax into 1000 km divided by 1000, so 1001 km. Okay, so this is almost same as each other. As you can see, this is almost same as each other. 1001 and 1000 is same, so these two can be cancelled, this is cancelled. So here V0 is equal to Vmax, V02 is equal to Vmax. So they have asked the fold difference. So V01 is Vmax by 2 divided by V02, which is just Vmax. Okay, so answer is 1.998, which is twice of it. All right. So you can see that if you take, basically you can either cancel it 1000 and 1001, but if you still divide it, it will come to 0.99. Okay, if you want to do that. And Vmax by 2 means you can write 0.5 Vmax. So always it will be final by initial. Fold difference, whenever they are asking, it will be always final by initial. So that's why it will be 0.9 Vmax by 0.5 Vmax, which will be almost 2, which is 1.98 answer. Okay, if you don't want to calculate, you can just cancel out this way as I showed you. That way also it will come to the, you can guess the right answer. Yes, very good, Satyam. That's the right answer, what you have said. Okay. Okay, next is in June 2018, one question was there. This is with line Vivo Berg plot. Okay, so came Vmax and came from a line Vivo Berg plot of a reaction where 1 by V is equal to 40 micromolar minus 1 per minute. At 1 by S is 0. What does this mean? This line where 1 by S is 0. So this line, we have taken x-axis 1 by S. So let's say this point. This point is clearly where 1 by S is more than 0. If you take this point, This here also the 1 by s is negative and less than 0. This is the point where 1 by s is exactly 0. Okay. So what is this particular point? That is 1 by v, that is y-axis at 1 by s is 0, is what point? What is the value? So this value they have given as 40 micromole minus 1 per minute. Okay. So here this point, it's actually the y-intercept, which is equal to 1 by Vmax. So we can say that this point 1 by Vmax, it is equal to 40 micromole minus 1 per minute. Okay. So if we have to find Vmax from here, we just have to take the Vmax on the other side and 40 to the other side. Okay. So it will be the 1 by 40. If you raise it to the numerator, this will be micrometer, and this was just minute, so it will be per minute now. Minus 1 will be gone, it will become per minute. Okay. So this is 0.25. Yeah, micromolar, if you take, it will be 0.025 Satyam. Okay, not 25 micromolar per minute. It is 0.025 micromolar per minute, and 0.0 and 0.67. Yeah, so the calculation is slightly wrong. So you can just, no, I think the second one it is correct. You have said 0.0067. Okay, so that is correct, because this is what is the x-intercept, and in x-intercept the value is minus 1 by k. Okay, so this value they have given to be minus 1.5 into 10 to the power minus 2. Minus minus will get cancelled out. So basically you will have 1 by km is equal to 1.5 into 10 to the power minus 2 uh, um, millimolar minus 1. Okay, so just bring this side and this side. So millimolar minus 1 will become millimolar, and km it will be equal to 1 by 150. So that will come to this one. Option 1 is the right answer. Okay. All right. Next question is from June 2017. This is from thermodynamics. Okay. 3 electron acceptors X, Y, and Z. They have redox potential E0 dashed. Okay. Of 0.15 volt, 0.05 volt, and minus 0.1 volt. Okay. So for a reaction B plus 2H plus and 2E minus, it gives you BH2. For this, the E0 dashed will be plus 0.05 volt. This is already given. See, whenever you have oxidation reduction reaction, there will be some oxidation reduction from where the electrons will be lost, and there will be a reduction in which the electrons will be accepted. Okay. So this will have a separate E1, E0 dashed, and this will have a separate E0 dashed. So E0 dashed 1 and E0 dashed 2. If you want to find out the delta G by using the formula delta G is equal to minus NF E0, then you have to take the net E0. Okay, net E0, which is including the sign. That is, it will be E0 dash 2 plus E0 dash 1, including its signs. Okay, so here already for 1 E0, they have given plus 0.05 volt. Alright, and they have asked that which out of these electron acceptors are appropriate. Appropriate means the reaction should be spontaneous. Which out of this will be appropriate so that the reaction is spontaneous? When reaction is spontaneous, we should select delta G to be negative. That means our answer delta G should come as negative. Now, since the formula delta G is minus N E0F, if we want this to be negative, delta G, if we want it to be negative and a negative is already there, that means our E0 should come positive. Then only minus and plus, it will be minus only. So delta G will also be minus in that case. Sakina, your previous answer was right. Why did you change the answer? So you have to resist the urge to change the answer when you are correct. Okay, that will lead to negative marking. You are right. Okay, think clearly. Negative we will get, delta G has to be negative. It has to come negative, then only the reaction will be spontaneous. So then only that electron accepted will be appropriate. Okay. So when delta G0 is equal to minus, okay, that means, yeah, Satyam, that is right. So if we are putting this positive, that means net E0 has to be positive, which means that this plus whatever you are taking from here, that should be positive. All right. So if we take 0.15 over here, so both are plus means it will be a positive result. So this x is a proper appropriate one. Even if we take y, even here also positive, positive, then also result will be positive. But if we take the c, then we have plus 0.05 minus 0.1. So this is giving a negative answer. Okay. So if we take this E0, this value of E0 here, then negative negative will become positive. In that case, delta G will become positive. Then this electron acceptor will not be appropriate. Okay. So so the Z cannot be the appropriate choice. Only X and Y. Okay. Yeah. Sakina, your answer is right. Very good. Satyam also correct. Very good. Okay. Explanations are also, you can calculate also. Taking this, you can calculate as well. Okay, see, they have calculated for x and y. You have got negative delta G, and for z you have got positive delta G. But even without calculation, if you just get the net E0, you can see for both of them it is positive, this is negative. Then you don't even have to put in the equation, because the rest of the parameters will be same. You just have to compare between the G and E values, because they're inversely proportional to each other. Okay. All right. Next question is from June 2015. This is also on enzyme kinetics, but this is a graphical question. Okay. So, how to solve this question? First of all, can anyone give it a try? How this question will be solved? Yes. No guesses? All right. See, we have to take from we have to take the maximum velocity. See, here they have given activity, right? Now, you can see all increments of 5, 10, 15, 20, 25. So this must be 30. This is the increment. All right. So this is the Vmax of B. These are all proteins, which means they are talking about enzymes only. For A, this is 20 only. And for C, it is around 14. Not 15, it is around 14. So Vmax of B is 30, Vmax of A is 20, and Vmax of C is 14. Okay. No, Satyam, that's not the right answer. So we have to compare their kcat by km, which is the catalytic efficiency formula, or you can also say yeah, Sakina, that's the right answer. Very good. Okay, catalytic efficiency, or you can also say specificity constant. That's what we do when comparing enzymes. This is called as kcat by km. Now, if we take their km, what is km? Km is substrate concentration required to achieve half of Vmax. If we take B, then 30 by 2 will be 15. Touch the B line and extrapolate it down. You will get the km of B, which is 1. Okay. That means 1 micromolar substrate will be required to reach half of the maximum velocity 30, which is 15. Same thing if you do for A, 20 by 2 will be 10. From 10, touch the A line and bring it down. Again, you are getting Km only as 1. From 14 also, if you take 7 and touch the C line, so let's say this is somewhere 7. If you touch the C line, then also it is coming to 1. So basically for all ABC, the Km value is same, which is 1. Which means you have to just compare their kcat value. You have to put in sequence their kcat value. So what is the formula of kcat? You would be knowing that Vmax is equal to kcat into Et. This is your very useful formula. We use it for many numericals also. So what will be kcat? Bring the Et here. Kcat will be Vmax by Et. And Et means protein concentration, which are already given. You just have to put it respectively for all of them. For B, if you have to find out the kcat value, so 30 divided by B concentration is 4. For A, concentration is 1, so 20 by 1 is what is the kcat value, and 14 by 2. So this will come to 7.5, this will come to 20, and this will come to 7, which means the maximum kcat is for A, the second kcat is for B, and the third kcat is for C. So option 2 is the right answer. I hope it is clear for everyone. Explanations are given, you can refer it later in the video. Then let's look at another beautiful question on thermodynamics. It's from June 2017. Okay. This talks about protein stability, which is represented as the folded and unfolded. There is an equilibrium between them. Okay. So before there were any sensitive calorimeters or thermodynamic parameters of processes were determined, they were determined by the following equation. The different thermodynamic parameters, that is delta H, which is enthalpy change, delta S, which is entropy change. So these all were given by this equation. These are standard changes in enthalpy and entropy. Enthalpy is the heat content of the system, entropy is the degree of randomness. So they are asking which one of the following statement is correct for estimating all the three parameters, that is delta G, delta H, and delta S. Should we determine the ratio of folded and unfolded 37 degrees C? Should we plot KEQ against delta H? I mean, as a function of delta H. Should we plot KEQ against delta S, or should we plot KEQ against temperature? Okay, so to understand this, we have to see something about Van Hoff's analysis. Okay, so Van Hoff's equation, Van Hoff's plot, we will take RT ln KEQ divided by 1 by T. Okay, so when we take the KEQ, actually fourth is the right answer. When we take KEQ and temperature, okay, so you will be getting the slope as the delta H. Okay, it will be negative slope. It is, you can see reverse line is there. So this is negative slope. And if you take any protein like chymotrypsinogen that is folded or unfolded, unfolded means denatured, folded means native, it will be highly affected by the temperature. Yeah, Satyam, that is right. 4 is the right answer. Okay. So delta H is approximately 500 kilojoule per mole, which is the denatured form. Okay, it is 500 kilojoule more higher in energy than the folded or native form. Why? Because if the native form has more and better non-covalent interaction, then energy required to achieve such a unfolded state will be where these bonds will be disrupted. And in the native form, they will have some sequestered hydrophobic groups from solvent. So exposing them will require an input of energy. So that is why a positive delta H0 value will indicate that folded state of a protein is a lower internal state than the unfolded state. So that is why protein folding is favorable, because by folding the protein, energy is decreased. And whenever energy is decreased, it's a favorable process. Yes, you are right. Correct, Satyam. That is the correct method to plot KEQ against temperature. Okay. All right. So this is your concept check and your homework. You have to give me the right answer. This is also based on thermodynamics. I'll just give you a hint and a heads up tip that the free energy change, it is given in minus. This is minus, okay, and that too it is given in calorie per mole. So what formula you have to use is delta G0 is equal to delta G, sorry, delta G is equal to delta G0. We know that standard free energy, if there is any concentration of substrate product or the temperature changes, then the free energy will change. It will not remain standard anymore. So delta G is equal to delta G0 plus RT ln KEQ in case of equilibrium, but in other cases it will be concentration of product by concentration of reactant. Okay. So ln, it is given by 2.303 log. Instead of ln, you can use 2.303 log. And delta G0, it's already given minus 1000 calorie per mole. Accordingly, gas constant also you should take in calorie per mole only, which is 1.98 calorie per mole. Temperature always never in centigrade, you have to always take in Kelvin. So 30 plus 273. And the concentration of product. So this is A to B, which means B is product. So B's concentration is 100 millimolar, which should be on the numerator. You have to convert it into molar first, and reactant will be 100 micromolar. Again, you have to convert it into molar. Then find out what is P by R. Take logarithm of it, multiply with 2.303, temperature in Kelvin, gas constant, add it up with the minus delta G0, and you should get the delta G. So let me know in the comment section who are watching the recording what will be the answer for this mystery question. Okay, that's all from my end. Reminder for Lakshya batch. Remember what our CEO of Biotecnika and Rasainika, Shikhar Suman sir, says, that effort is the key to success. Okay, if you just put the effort, right, results are just the certificates. Don't worry, put in your effort for this February exam. If you cannot, it's okay. We are still there. So now you at least try from your end. You will be satisfied that you have tried. Okay. All right. Thank you, everyone. That's all from my end. I'll see you again on Thursday.